department resources are associated with. For example, if we deploy resources into Azure and we give them a department tag with the value of marketing, then we can discern that all of those resources with this department marketing tag are going to be associated with the marketing department. And we can do this for various departments in our organization. And this helps with doing things like cost analysis, where we're trying to derive how much money is the marketing team spending on resources inside of Azure. And we could do this for various departments in our organization. We could also break this up into things like maybe we want to say what resources are resources that are being utilized inside of the United States and what resources are being utilized in, for example, Europe, so that we can determine our costs geographically. Now, as another tagging convention example, we might want to organize our environments into production, dev, or test workloads so that we can discern what Azure resources are part of production, what's part of dev, what's part of test. And there's various ways to organize these things. We could create a production subscription, a development subscription, a test subscription, so that we kind of have almost these deployment zones for our workloads whenever we're doing things like dev tests and pushing to production. But this is just another one of those ways to show that tags are flexible, and any use case that we can dream up for using tags, well, we certainly can do that. And when we're creating tags, it's important to understand that for tags for the names, they can be 512 characters, and the value can be 256 characters, with the caveat that for storage accounts, the name can only be 128 characters long. Now let's take a look at our diagram here, where we have a marketing subscription with some resource groups for database and web application running inside of the subscription. Well, if we wanted to understand whether or not this marketing subscription is part of a production workload, well, we could use that tagging convention for production so that we understand that this marketing subscription has some production resources in it, and maybe it has some development resources in it as well, and we could tag those accordingly. Now that we've taken a look at this, let's look at the resource tag assignment hierarchy. To help us understand a few things. Firstly, I want to say that tags are not inherited from the assignment scope. So, for example, this department marketing tag that we have here and the marketing subscription is not going to be inherited by all of the underlying resource groups and resources that they contain. We'd have to actually go to each of these resource groups and assign it the appropriate tagging, and the same would be the case for the resources that they contain. They are not inherited. Now, we could certainly use something known as Azure policies to create a policy that forces this inheritance of these tags for things inside of resource groups, for example, but it is not something that is going to be natively supported by just creating tags. Now, another thing that I want you to keep in mind is that resources can have up to 50 tags at a time. So we don't have an unlimited capacity to assign tags, so we need to think very carefully about what tagging conventions we are going to use inside of our organizations before we actually start using them at scale, so that we can plan appropriately and also have space for more tags in the future should the need arise. Now let's get into our demonstration piece. For our demonstration here, we're going to log into the Azure portal inside of the Azure Cloud Sandbox here on the platform. We're going to go through a process of determining what tag we want to use here. This is going to be a bit of a creative component here where I'm going to let you decide what sort of tagging convention for name value you want to use in your environment. I will use one for the demonstration. However, you certainly don't have to use that one. You can come up with your own if you'd like. And then we're going to tag the resource group that we have inside of our Azure Cloud Sandbox, just so that we can walk through the process of actually assigning a tag inside of the Azure portal. So let's make our way over to the Azure Cloud Sandbox and get started. Alright, gurus, so here we are inside of the Azure Cloud Sandbox. So we'll get started by coming up to the search bar here and typing in resource groups, and then we'll select resource groups under services here. We'll see we have the one default provided resource group, which our user is scoped to with its role assignment. We'll select it here, we'll minimize this portion of the blade, and we'll click on tags in the left-hand blade of this resource group. And what we'll see here is any of the taggings that we have associated with this resource, which at this time is none. Now that we've logged into the portal, we need to determine what tagging convention we want to use. And this is a part where I'm going to let you choose to go ahead and pause video and create your own tag name value pair if you would like to do so. But for my case, I'm going to go ahead and use one. I'm going to type in MS resource usage, and I'll select it here, and then I'm going to give it a value. Let's say, for example, I want to use the value of that this is the production, which will let me know that any resource with this name value pair is part of the production environment. Now, something to keep in mind with these tagging inside of our resources for Azure is that we can't reuse the same name. So if I were to have an env name here and this one be test, I would not be able to then use the same name for another tag pair here, because the name must be exclusive and unique each time that you use it. So you can't use it in that way. But you could develop something like this, MS resource usage here, and then you could have a different value where you're saying it's part of the development environment. So let me go ahead and delete these here. And then I'm going to click apply, and this is going to apply this tagging convention to our resource group. And we don't have any resources inside of this resource group as of yet, but it does not inherit them. And if you want to test that, you could even do a little bit of extra work here, even though we're done with the demonstration, and deploy some resources to see that it actually doesn't inherit the tags of the resource group. And here in the browser, in another tab, I actually have a ARM template from a Microsoft provided quick start template that we could actually deploy if you want to. I'll provide a link to this in the resources of this video. However, this is not part of the demonstration necessarily, and you certainly don't have to follow along. You can go ahead and continue on past this point, but if you'd like to, it's just something else you can do to kind of play around and get familiar with the environment, as I like to provide certain scenarios and different experiences inside of Azure to help you get your hands on all of these services. So if I go to my other tab here, you see I have this. I'll copy all of this here from the raw GitHub link, come to the search bar, and I'll type in ARM template. I'll click deploy a custom template under services, and here I'm going to build my own template in the editor. I'll select all, I'll paste in what is in the clipboard, click save, and it's going to select some things such as the resource group that we're scoped to and the region for me. It's going to use the region based on the resource group, and then I'm going to create some things here using this template by filling out these parameters. We're going to have to provide a globally unique storage account name. So I'm going to call this the AZ104 STG Demo 01, and hopefully that's going to be a unique name. Otherwise, it will tell us it isn't. And then provide an admin username for the virtual machine this is going to deploy. I'll use Azure User. And then I'll provide my password here. And then a DNS name for the load balancer public IP. I'll go ahead and just use AZ104 storage Demo 01, same as the storage account, why not? And then the VM name prefix here, we'll leave all these things set to the default, and we'll click review and create. It's going to validate the deployment of this ARM template here that we've gotten from the quick starts on the Microsoft Azure GitHub. We'll click create here, and it's going to go off and deploy these resources. So I'm going to come back once this deployment is finished. Hey gurus, I'm back, and the deployment from this ARM template has completed, so let's go ahead and go into our resource group here. And inside of our resource group, again, for this resource group object, we see we have our tag that we set here. But if we go into any of these resources that are now contained within this resource group, what we'll see is that they are not inherited. For example, let's go to the My VM 0 here, and if we go to tags, what we're going to see is it has no tags, and that's again because tags are not inherited further down in the scope of assignment. So you assign it the resource group, it's not going to be inherited by all the resources that are contained by that resource group, and so on, because that's just how tags work. It's not a default behavior for them to be inherited. You could do things like use Azure policy to enforce that kind of behavior, or you could even do more custom solutions such as creating Azure CLI or PowerShell scripts where you're using specific commands and commandlets to get all of the resources. Say, for example, in this resource group, you could say get AZ resource using an Azure PowerShell commandlet, get all the resources in this resource group, and you could hard code that resource group string name, or you could pass it in as a parameter to your script. It will get all those resources, and then you could use another commandlet like set-az resource where you're going to go through and then set a tag for all those resources that you're now looping through inside that resource group. So there's just a couple of ways that you could actually use some automation to apply tagging at scale for a lot of resources in environments where you might have hundreds of resources inside of resource groups or even in subscriptions. All right, gurus, now that we've completed this demonstration and I've gone a little bit above and beyond in showing you some of the things for tagging inside of Azure, let's go ahead and make our way back to the slides for a quick review. Alright gurus, congratulations on following me all the way through this lengthy lesson about tagging resources inside of Azure. Now, the key takeaways from this lesson that I want you to have are that we understand that these tags, these name value pairs, can be used to do all sorts of things inside of Azure, and the sky's the limit with this because it's really a flexible type of resource. And we can use it for things like managing resources via tags. We can use it for cost analysis on resources based on tag. We could use it for things like performing automated operations by doing things like getting all of the resources, such as virtual machines, running inside of Azure that are part of the development workload, using that development tag. And then we could perform things like update operations or shut all of them down. Whatever we need to do with the tags, they're a flexible type of object inside of Azure. Now, as we saw in the demonstration, tags are not inherited from a higher scope like a resource group or subscription. Each resource must be tagged independently, and there's various ways that we can use Azure services such as Azure Policy to enforce tagging inheritance, or we could actually create automation scripts using PowerShell or Azure CLI to be able to do things like this as well. Alright gurus, thanks so much for joining me in this lesson. I look forward to seeing you in the next one. Hey gurus, I'm Chase, one of your Azure training architects here at ACG, a Pluralsight company, and it's in this lesson, locking and moving resources, that we're going to start off by describing resource locks inside of Azure, and then we're going to talk about the types of resource locks we have and their functionality. This will then present a unique opportunity to talk about moving resources inside of Azure, and then we're going to go through a demonstration in the Azure Cloud Sandbox where we're going to go through locking and moving resources and talk about how that impacts resources in Azure, and then we're going to bring it back to the slides for some key takeaways. So to get started, what are locks inside of Azure? Well, locks in Azure are this feature that we have to put a lock on a resource, and what this allows us to do is override permissions to those resources for those authorized users. And we can put locks on various scopes, such as subscriptions, resource groups, or individual resources. And these lock restrictions that we put in place are going to apply to all users and roles. So regardless of a role assignment of a user and what permissions we may have, they have to abide by these resource locks, which will override their permissions. Now, our first resource lock type here is a read-only lock. And this is going to allow authorized users that have read functionality to read the resource, but regardless of what your delete or write operations are to update resources, this read-only lock will override those and not allow you to perform delete operations or update operations for resources that have this read-only lock. And then the next lock type that we have is a cannot delete lock. This cannot delete lock allows authorized users with the necessary role assignments to read and modify resources, but they cannot delete resources. So they can perform read operations and specific write operations. As long as one of those write operations is not deleting that resource, they're going to be successful in that operation. And resource locks, regardless of what type of resource lock we have, are going to actually be inherited all the way from the parent scope. So if we have one assigned here at the subscription, as we see with marketing subscription, it's going to be inherited by all of the resource groups and resources that are inside of that subscription. That is the opposite of how tags work in Azure, as we saw in a previous lesson, where they're not inherited by default. In this case, with locks, they are inherited from the assigned parent scope all the way down to all of the child scopes and child resources that they contain. Now let's get into talking about moving resources, since we're talking about locking resources here. Moving resources is the process of actually moving resources that are contained in a specific place in Azure, for example, inside of a subscription, and more specifically, these resources nested inside of a logical container like a resource group. Now we can move resources inside of Azure between resource groups. So we could move resources from this dev resource group here to the test resource group if we wanted to do so within this marketing subscription. But we can also move resources inside of Azure from subscription to subscription. So this is cross-subscription resource movement here. We could move from the test RG resource group inside the marketing subscription to the prod resource group inside of the engineering subscription, because we can move these resources across subscription. Now, it's a bit of a different style of moving resources, and it looks a bit different inside the portal when we're doing it across subscription, because you have to be able to have certain permissions to be able to perform write operations inside of another subscription. So typically those subscriptions will be associated with the same tenant. Now that information is a bit outside the scope of this lesson, and that will make more sense in later lessons when we start talking about Azure Active Directory tenants, but for now, just it's something to understand at a high level that moving resources between subscriptions will require specific types of role assignments for subscriptions, as opposed to just moving resources inside of the same subscription. Now, since we're talking about moving resources and locking resources, moving resources is a sort of write operation, right? Because we're writing resources, we're reading from them, we're getting all the details from them, and then we're writing those resources to another location inside of Azure. And because of that, we are going to use this as a frame of reference for locking resources. For example, if we were to put a read-only lock on this prod resource group here, we would not be able to move these resources inside of this prod resource group in the engineering subscription. And that's because we have a read-only lock that is blocking update and delete operations on these resources. Now, if we had a delete-only lock, we would be able to move these resources by performing those update operations to other subscriptions and other resource groups. And we could read those resources as long as we have the role assignments to do so. But we're not going to be able to delete those resources with a delete-only lock. Now, this brings us into our demonstration where we're talking about locking and moving resources. First thing, we're going to log into the Azure Cloud Sandbox to get started, and we're going to create a VM resource, and we're going to use this resource to work through some of our demonstration here of locking and moving resources. We're going to add a delete lock here to see whether or not we can delete a resource. So let's hop into the Azure Cloud Sandbox and get started. Alright gurus, here we are inside of the Azure Cloud Sandbox, and the first thing that we're going to do is we're going to go to our resource groups here. We see we have mine here in the recent. You could go to resource groups, or you could search resource groups here in the search bar. But I'm going to go into it, and what we see is we have a resource group, as we always do by default, in the Azure Cloud Sandbox that our user is scoped to. We don't have any resources inside of this resource group, And if we look at the locks under settings of this resource group here on the left hand blade, we see we have no resource locks on this resource group at this time. And that's something important to take note of because we're going to create one. But first we need to create some resources. Now we can go through and manually create resources by going to these services such as virtual machine here in the search bar, but we could also quickly provision resources using ARM templates. So I'm going to do that here, and I'm going to just go ahead and go to a new tab. And in this tab, I'm going to type a Google search term here, and I'm going to type Azure ARM template quick start GitHub. And this is going to provide me the GitHub search engine result for the Azure Resource Manager Quick Start templates. Once I get into it, here we'll see if we go to Quick Starts inside this GitHub repo, we're going to see all of the templates that are in the Quick Start broken down by resource provider. Now we can play it safe here. We'll just go to Microsoft.compute here in this repository. We'll just pick one of these simple ARM templates here, like this first one. You can pick whichever one you'd like. Just understand that inside the Azure Cloud Sandbox, you may not be able to deploy everything, so that's something to keep in mind, just because there are some restrictions inside that environment for obvious reasons. So I'll click on this Azure deploy.json here. I'll click raw to get the raw link for it. I'll copy all of this using my Command A or Control A, depending on your system. Come back here to my Azure portal, and I'll type in ARM template, and I'll select deploy a custom template under services. And here I'm going to build my own template in the editor, select all, paste from the clipboard, click save, and then I'm going to start filling out my parameters here. My resource group, I'm going to provide my admin password, as this is going to provision a virtual machine, my admin username, and my DNS name for the load balancer public IP. I'll just go ahead and give this a label of ACG demo 104. And then we see here the VM size. This is what I was talking about. There are certain policies in place to prevent certain resource types and certain resource usage, in this case VM size, inside of the Azure Cloud Sandbox. So we'll just change the size to something that is agreeable with this policy. Click select. That works. We'll click review and create here. And this is going to go off and create this resource. Once it passes validation, we'll click create. And we'll be back once this ARM template deployment has created resources for us so that we can move on with our demonstration in adding a delete lock on our resource. So we'll be back once that's finished. Alright gurus, so we're back and our ARM template has finished deploying for this demonstration, and now we have some resources here that we can play with. Now I'm going to drill into this resource group here and we'll take a look at what we have. Minimize this portion of the blade here under essentials, and we see we have a load balancer, public IP for that load balancer, virtual machine, VM disk, virtual network containing our virtual machine and its network interfaces, of which it has two, a storage account that is probably being used for diagnostics in this case, and a network security group to control network traffic for our virtual networks, subnets, potentially even the network interfaces for this virtual machine. So we got a few things here. Now, this is going to bring us into going back to our settings here on the resource group and looking under locks, and we're going to add a lock here. We're going to provide a lock name. We're going to call this don't delete me, and we're going to make this a delete lock, and we'll click OK here, and it has now assigned a delete log type named don't delete me at the scope of this resource group here. And we could edit this and we could change the, and we'll click OK here, and it has now assigned a delete log type settings here on the resource group and looking under locks, and we're going to add a lock here. We're going to provide a lock name. We're going to call this don't delete me, and we're going to make this a delete lock, and we'll click OK here, and it has now assigned a delete log type named don't delete me at the scope of this resource group here. And we could edit this and we could change the log type to a read only, or we could also add notes to this so we could understand what this lock is for if it didn't have a easily understandable name. And what we'll notice here is now if we go back to the overview here, if we try to delete any of these resources, for example, if we try to delete all of them, and then we come over here and click delete by clicking on the ellipses, click yes to confirm to delete all of this stuff, go ahead and click this checkbox here to apply force delete for select virtual machines and virtual machine scale sets, and then click delete. it is going to fail on this operation. And that's because, as we see here, by the output of this notification in delete these resources. And that's because delete locks are going to only update operations or delete operations on this virtual machine. So we would only be able to do things like reading the details here inside of the app. Click at it, and we'll change this lock type here from a delete lock to a read-only lock. We'll click OK. Now, there's some limited functionality inside of the Azure Cloud Sandbox that prevents us from doing this for obvious reasons to prevent exploitation in these environments. Authorization through a role. We have this inheritance is an update operator in the next one. Howdy and welcome, gurus. I'm Chase, one of your Azure training architects here at ACG, a Pluralsight company. And it's in this, then we're going to start a series of demonstrations, starting with demonstration for even using public cloud environments in the first place. Utilization, for example, model, everything. And that's for free, or you'll get free up to a limited point. And then there are other services you may have to pay for. Then there's pay-as-you-go, where you're paying truly for what you're using and only that. Then there's enterprise agreements, and then there's even subscription type such as a cloud solutions provider, and this is where you're as a customer a resource. And then there's various components that affect costs, like location, for example, and this can cause different services to cost certain amounts that you may see cost less or more in other regions inside of Azure, because Azure is broken up into geographies such as the United States, and then there are various regions inside the United States. And first one is we need to select as best practice, and this is to scale how much they will. And this is the Microsoft Cost Management tool. The Microsoft Cost Management tool, as we're going to see in this demonstration, allows us to analyze our costs by performing specific cost analysis functions, and then it also helps us create budgets, which we're going to learn more about in a later lesson in this course. So without further ado, management. We get filters for things. Public face demonstration with the team of what your workload is, workloads that we would like to have running in Azure. And then we also have hey and welcome, gurus, and all the things that we've covered. The first step is defining the governance needs of the organization. What sort of policies and standards do we want to put in place? Do we have to abide by any sort of data sovereignty such as GDPR, or maybe we have to abide by some sort of regulatory phase where we're planning which tools will be used to implement governance inside adoption phase, where you're implementing cloud governance for the organization using a cloud strategy that you've defined. Governance service measure, where we have an accumulative cost for those Azure resources that we've used. It's automation to bring all the things together from this section. Compliance standards, and as we saw in this section, we have read-only locks that prevent any other operation other than reads. As long as you're an authorized user to read, you will be able to read, but you won't be able to do anything else. And then delete locks that prevent delete operations, but still allow authorized users to perform those read and update operations on resources. Now, if you haven't, even though it's not necessary for this course, I just wanted to bring it up because it is something that is going to provide some exciting features for a lot of this cloud governance strategy. And I always believe that researching things, even if it's not immediately necessary, I look forward to seeing.
Hey and welcome, gurus, to this section. In this section, we are going to be talking all about Azure Active Directory. We're going to be covering the identity portion services. of the Azure cloud. And as we go through this section, we're going to learn a little bit about several identity topics. We're going to learn about Azure AD, where we're going to learn about the identity and access management basics we need to understand Azure AD. We're going to describe what Azure AD is as the identity service for the Azure cloud. We're going to take a look at what an Azure AD tenant is, being a specific service instance of the Azure AD service. And then we're going to look at the Azure AD architecture and how that fits into the Azure cloud. We'll then compare Azure AD and Active Directory so that we understand the differences between these services, and then we're going to actually work with Azure AD tenants inside of the Azure Cloud Sandbox. Then we're going to learn about Azure AD users. We're going to describe users, talk about the types of users we have in our Azure AD tenants, and then we're going to go over the architecture of how these identity resources exist inside of the identity repository. That is our Azure AD tenant. Then we'll go through some demonstrations on creating users and the methods by which we can do so. And then we're also going to cover how we can use Azure AD groups to manage our users. Then we're going to talk about the types of groups that we have and how we can assign membership to those groups. And then we're going to talk about how we can manage our devices using Azure AD as an identity service to give device identities, and we're going to also cover how we can join devices to our Azure AD network. Then we're going to cover administrative units in this section, where we're going to be talking about administrative units and also talking about things such as self-service password reset. Now, as we go through this section, we're going to learn everything we need to know to prepare for the exam for the AZ-104. Alright, Gurus, that's all my time for now. Thanks so much for joining me in this intro to the section. I look forward to seeing you in the lessons throughout the section.
Howdy and welcome, Gurus. I'm Chase, one of your Azure training architects here at ACG, a Pluralsight company, and it's in this lesson conceptualizing Azure Active Directory. And we're going to get started by laying the foundation with some identity and access management basics. Once we've done that, we're going to use that foundation to get into talking about what Azure Active Directory is, and then we're going to take a look at the Azure AD tenant architecture so that we can understand the bigger picture and the role that Azure AD plays for our cloud-based environments. Then we're going to take a look at some of the Azure AD features and the differentiating features between Azure AD licensing types. Then we're going to compare Active Directory, which is an on-premise identity solution, to our cloud-based solution, Azure AD. And then we're going to wrap up this lesson with some key takeaways. So without further ado, let's get started. So to begin, I think it's important that we first understand when we're talking about identity and access management, we're talking about security, really. Security traditionally had been focused on network security perimeters, but with the invention of the public clouds like Azure, we've moved to a more identity-centric focus on security. For example, let's draw some parallels here as we work through the slides. See here we have an unauthenticated entity. It is not authenticated because it has not provided information to be authenticated against. For example, this was like when you first visited this platform and you saw certain parts of the platform, but certain functionalities such as training content or labs were behind a paywall. Now, once you signed up for this platform, you were given an identity profile that you could authenticate against using credentials like a username and a password, or an email and a password. And you use these to authenticate into that identity, and once you've assumed that identity, you had access or authorizations that were permitted for your identity specifically on this platform. And this could be an example of having the privileges to use this training content. Your identity has those authorizations. And in a high-level view, this is identity and access management very simplified. But this gives us the foundation that we need to understand what Azure AD is and what it's doing. Azure AD is our identity and access management solution for the cloud. It provides our cloud-based identities that it contains, and it allows them to access resources. And when I'm talking about Azure identities, I'm talking about these users, for example, could be a type of identity. You could also have other types of identities, but let's just pick on users for a moment. Users could be things like our employees, and these employees are going to authenticate into these identities that we have in our Azure Active Directory, and they're going to be able to perform specific actions that they're authorized for on our Azure resources. And this brings us into talking about the identity security focus component that Azure AD provides, where we have security functionalities such as multi-factor authentication, or the ability to control resource access for these identities using things known as role assignments, which we'll learn about more later in this course. But for now, just understand that we have an identity. This identity has a role assignment, and that role assignment provides it with the privileges to perform specific actions on a resource that it's trying to access. We also have identity security functionality such as conditional access policies, where we control the access of specific resources based on conditions of a policy that we set up. For example, if an identity is trying to sign in from an untrusted IP, deny that access, or require multi-factor authentication. Now that we've discussed what Azure AD is, let's take a look at an Azure AD tenant architecture. It's important that we understand that Azure Active Directory is a global service that spans the Azure cloud. And while it is a global service that spans the Azure cloud, our specific instance of this service that we get to use is going to be scoped to a geography. So for example, when we create an instance, it's going to create that instance in whatever geography we were in when we created our Azure tenant for the very first time. For example, if we create our tenant in the United States, it's because we were in the United States when we created it at that time. And it could be the same for Europe. If you're creating an account from Europe, you're going to end up with an instance inside of the Europe geography of the Azure cloud. Now, all of these different tenants can exist for various organizations alongside one another. For example, if we have a tenant here inside of the United States, as we see, another organization, not even affiliated with ours, could have another tenant that exists alongside ours inside Azure Active Directory as a service. And this is possible because we have our own instance of this service known as a tenant. So let's take this a dive deeper into the tenant level in terms of architecture. We have our Azure Active Directory tenant, and this tenant is our instance of the Azure AD service inside of the Azure cloud. Now, when we create our Azure Active Directory tenant, we're going to get a default domain name for our tenant. And this typically follows the form of, for example, a tld.onmicrosoft.com. And it's always going to follow this format of our prefix .onmicrosoft.com. Now, when we're talking about Azure Active Directory, I don't want you to get lost in the terminology, so I want you to understand that you may hear it referred to as an organization or a tenant or a service. The resources have role assignments to perform actions on subscriptions that our Azure Active Directory is associated with. And this can happen for multiple subscriptions. For example, this trust relationship that we establish between our tenant and our Azure subscriptions is a one-to-many relationship. One tenant can be associated with multiple subscriptions at a time, providing those identities that exist within it access to Azure resources, as well as privileged identity management. Privileged identity management at Azure AD, where we have things like B2B collaboration, risk management functionality, environments into the cloud, both on-premise and in the cloud. We also have group policy, and we can extend the functionality between Azure Active Directory and Active Directory is a global service. In the later lessons in this section, example, accessing those resources.
Shamir, secret sharing. It's 3 a.m. Only good. About their experience at Google. Of course, I had to read this because this just seems crazy. I have not read through pretty much any of it, other than I just read this part right here, which feels wild. And he gave me kind of a little bit of like, hey, this is what's happening. So let's do this. TLDR, I wrote this whole thing as a TLDR, but now it's this size. Oopsies. Pre-watched. I pre-watched this text. I did format it in tech. I did format it, so I do know how the ending goes because I was formatting it and I read the ending on accident. How to work 10 hours a week as a software engineer for 7 years for $400,000 a year. Everybody take out. I was expecting to see a bunch of Pepe notes going on. Where's the Pepe notes? All right, anyways. Engineering estimates are so fuzzy and the org so broad that's not really used as the measure of productivity. Okay. For flat teams, 12 per manager, 70 per skip at the company without micromanagement. If your manager is too busy to know exactly what your day-to-day is, it's easy to pass off slow work as challenging work. Okay, yep. Thank you for the essays. So first off, this is actually kind of wild. 12 people per manager, 70 per skip. There's like a prescribed amount. For every 6 managers, there's a skip level. For every 12 employees, there's one manager. Kind of wild. It helps when your manager has a disconnect, stopping them from fully understanding your work. Are they a PhD who mainly reads ML research papers and worked on ML theory, doesn't code, never really did, and only works on cross-team collaborations with other managers, and doesn't have a good idea of the part of the code base you work in? Okay. A lot of work is ML modeling based and requires experiments that may or may not pan out. Not launching is a presumed risk of any experiment. Plus, many ML/data analysis/investigatory work doesn't require checking in much code. Document trail of artifacts. By the way, you can really tell this is Google when they say artifacts. Google is all about technical artifacts. They want you writing up everything. Everything needs to be written to a T. All right, the promo system rewards impact and complexity and leadership, which is easier to claim when you were the sole owner of a project. So many projects are designed to be highly independent. So often your teammates don't know much about your work. This does actually make sense. Just throw in leadership in there. Lead your own personal project. Complexity unknown. This sounds like the dream. Given the old promo system and quid pro quo solicitation of performance feedback, everybody's too scared to give anyone else negative feedback at the peer level. Oh yeah, because if your promos are directly tied to peer feedback, then you have it's like the inverse prisoner dilemma. Like, no one wants to tell because you're gonna know, and then everybody else, oh baby. Why would you give critical feedback to someone which they can read after when you will get the manager/calibration committee level? If your manager doesn't even know what you're doing, the other managers have no clue whatsoever. So given only positive peer feedback plus clueless managers arguing calibration with their gut instinct. So your manager feeling you are smart can be enough. Plus your manager is incentivized to argue for you since having a low performer looks poorly on him. I can see that. Stamp performance rating with no debate from others in the collaboration committee. Damn. Add in the constant churn of reorgs and new managers/skip/teammates, and you constantly get a fresh start for their impression of you. So it's often about everyone's first impression of you. Oh my goodness. Historically, we only need one real mandate hour. Has a really low fire rate compared to other companies. Historically, they felt they only hired the best, so were nicer than other companies and were more willing to give more chances, plus lowered their allowed plateau level from 5 to 4. Though, recently they've changed the percent of people who get the lowest 2 buckets in perf reviews. Okay, yeah, so if you don't know what a plateau level is, there's this idea that you can work at a company, an L4, a engineer coasting. While the bar to get promoted is pretty high and has been. Keep in mind, you're still getting better at your job every year. So if you truly don't care about getting promoted, you can work for fewer and fewer hours each week as the years go on. The crux of the issue is managers hate spending time on perf reviews, so ignore it all year and then have to decide everyone rating in a single 8-hour day of calibration. Maybe an extra half day is used before the pre-sort and the half day after the tough cases. They can actually deeply read and understand everyone's CLs, design docs, bugs, design challenges to truly understand complexity and hard work in 8 hours? No. Every manager is biased and says their reports are performing better than other managers' reports. It's too subjective. So how do they break the tie amongst themselves? Do they use objective numbers like revenue? No. They argue that they can that can be biased per team. So what do they use? They use artifacts. The technical artifacts. I've heard of these being just fantastic. You just got to write about what you do. You don't actually do anything. You just write it. So you're not actually elevating on if you worked hard. You're elevating on if employee B had to do the same project but wrote 10,000 word design doc to explain the 100 lines of code they planned to write, checked in their 20 broken iterations of that code, created a tracking bug with 40 sub-tracking bugs, partnered with one engineer who rubber stamped all the code reviews, faster iteration time, caused production outage, wrote a post-mortem, logged more bugs, had no idea how the system worked, and wrote 1,000 lines of technical debt, laid in hacks instead of 100 lines of code for their implementation, launched something that may or may not be working, skipped adding any instrumentation or spending any time to look up or use existing metrics, but it must be fine because nobody asked them to write another post-mortem yet. As Trump says, if we stopped testing, we'd have fewer failing cases. Then wrote an elaborative 10,000-word launch doc touting their success. Obviously, employee B performed better. Look at the complexity of that project and how much they did. I mean, it's a really good point. Consistent churn will always look more impressive than inconsistent excellence. Your job is not really to write good code for the company or increase company revenue, though that may happen incidentally sometimes. It's really to construct an array of artifacts that look impressive to the bosses upon cursory glance. And on works a great place to toss these into the void. Bug notes. Split all bugs into at least 10. It's more complexity of problems you are solving. Stock. Don't forget to 2 to 3x these in size months after the launch before perf. It's so good. It's so true. Let's see. But if you have a lax few close teammates and a lax manager, you can all enable each other in your laziness. Only, or maybe they skipped those two and got back aggregate statistics. But knew nothing else. In one day, I understood and could debug their system better than any of them. But those same people are still getting promoted at the exact same annual reviews and other deficiencies. It's pretty easy to get here. And you should just change companies because getting promotion via an interview is way easier than getting an internal promotion. So let's say you've coasted for a while. And for whatever reason, demotivation, medical, addiction, focusing on marriage and family, you got a low rating at any point or a long plateau. You can still do all of the above and not get underpaid in the meantime. Hey, P.S. I'm still simultaneously worked both. 2x salary will always have a negative perception. That fight back is all but impossible. You know, because sometimes things happen, right? You focus on family and marriage, you do things differently, and you really do just, you gain a negative perception because of outside influences, because of things that you're taking differently. Or say you used to work 60 hours a week, and now you're just like, hey, a day. I want to go work and make, I don't think it's worth it. Now, obviously, it's very easy for me to say that because, you know, I already get to work at Netflix. I've established and made great things. I've done good things that I really am happy and gets by. The hard way. I want to know.
About a year ago, I received a mildly discouraging comment on one of my YouTube videos. At the time, I had been working on my indie game and game engine for about a year. I made some progress, but it wasn't totally obvious how far along I had come.
That's a really cool game. That was a really cool game right there. I love, this is a really great little, yeah, it's a, right? Whatever the soup du jour. I think the problem is that there's a group of people that think the only good result is the completed project. Whereas I don't look at a completed project as the goal. The goal is to learn what I'm trying to learn.
About a year ago, I received a mildly discouraging comment on one of my YouTube videos. At the time, I had been working on my indie game and game engine for about a year. I made some progress, but it wasn't totally obvious how far along I had come. So the guy writing the comment seems justified in what he was saying, at least in some way. Here's what he said. What's wrong with just using a commercial game engine? I have a feeling you will have great. So the guy writing the comment seems justified in what he was saying, at least in some way. Here's what he said. What's wrong with just using a commercial game engine? I have a feeling you will have great grandchildren before a game is ever done with this. Now, I don't mean to bag on him. I actually think he's coming from a fairly common place. Most of us aren't encouraged to take the harder path, and so it's pretty normal for many to assume something is too difficult before ever trying it. And in fact, at that time, my game really didn't look like much of anything. It was just kind of a white square sort of bouncing around. If you were looking at it, you wouldn't have thought much of it. If all you ever did was pay attention to mainstream programming articles and top page Google results, I think you would be pushed into a similar mindset. Basically, anything that is mainstream in the programming world, you're presented with a view which highly emphasizes being convenient and using tools and not reinventing the wheel as much as you possibly could. And this is the dominant mindset. But I actually want to argue that this easy way of doing things, this always use someone else's tool mindset, is actually to your own detriment. And that doing the opposite of that is probably the best thing for your career. And I mean that not only in terms of the financial success that you will get, which you will actually get more money if you do things the hard way, but you will also be able to pursue more interesting creative projects and ideas that you wouldn't otherwise be able to pursue. So in the course of this talk, I just simply want to argue what this mindset is, and I want to actually show you what you can.
Be sure to acknowledge that your experience limits the usefulness of that knowledge. So be respectful of your coworkers. Always, as TJ always.
McKinsey, on the topic of software development productivity, is getting a lot of flack at the moment. It's provoked strong reaction from
I remember from the 90s and early 2000s, where they used to say, must be able to hit the ground running. It basically means we want you to have written half the code, come with your own libraries, and just chug it out, and we're not going to worry about it.
The state-of-the-art in software development approach is continuous delivery. It's widely practiced by some of the most effective software companies in the world. And